So before we move on to this session, let's have a look at our last lesson and our last question to recap on the strategies that we've been looking at. So we can see from this question that Olivia has drawn these two diagrams. We can see them just below as circles, one labelled 2/5 and one labelled 1/3. And we're being asked, are these fractions equal? And we're being asked to explain our answer. It gives us the hint we can draw a diagram. So I want you to pause the video and I want you to either look back at your previous work or try this afresh to answer question 5 from our last lesson. Olivia has drawn these diagrams. She says that the fractions are equal. Is Olivia correct? Explain your answer. Pause the video, try and work out how you would answer this question, then come and join me when you're ready to discuss the strategy we've used. So let's have a look at how we can solve this. So our question is saying that Olivia has drawn these diagrams. So let's have a look at these diagrams first. We've got the first circle, which is 2/5, which means that we're working with fifths, which means as a fraction, that circle should be chopped into 5 equal parts. And the bottom circle, we're being told she's working with thirds, so that circle should be 3 equal parts. Now if we look at both those circles, we've got to make a decision. Has she actually drawn fifths on the first circle, and has she drawn thirds on the second circle? Once we've made a decision on that, then we can look at the numerator. We can look at the idea that if she has drawn 5 equal sections for that first circle, has she shaded in 2 of those 5 equal sections to make 2/5? And with the bottom one, has she shaded in 1 of those 3 equal sections to make 1/3? Now, to take our first idea of, has she created 5 equal parts and 3 equal parts? Well, if we look at that circle, we can spot that one of those sections on the 2/5 diagram is far bigger than all the others. So this cannot be a fraction. It must be a different amount. So looking at it, my mental maths would say that that final one, which is far bigger, could actually probably be chopped into 2 separate parts to actually give us 6. Looking at the bottom circle, they look roughly the right amount, and by drawing a diagram of this I can see more clearly. And here you can see that I've drawn my bar model to show fifths. Each one of those 5 parts is equally distanced, and that means it's 1/5, and the second bar model is split into 3 equal parts to give us thirds. So now we're looking at this idea of 2/5 and 1/3. We know that I've got a bar model showing fifths, we know that I've got a bar model showing thirds. So now I'm going to concentrate on my idea of the numerator. And here we can see that I've shaded in 2 of those fifths, so 2/5 in blue, and I've shaded in 1 of those thirds, 1/3, as blue. So now I can start that comparison and comparing to see, are they equal, are they the same size, are they equivalent? And I've used my red line to draw straight down just to see, are they the same size? And we can see here that 2/5 is greater or larger or bigger than 1/3. So 1/3 is less than 2/5. These are not equivalent or equal. So is Olivia correct? No, she's incorrect, because 2/5 is actually greater than 1/3. And the first mistake that Olivia has made is she hasn't separated circle 1 into fifths. She just separated it into 5 parts. They're not equal. And that's prevented her from moving on to the next bit, where you shaded in 2 of those 5 parts and 1 of those 3 parts from the bottom circle to compare them. So Olivia has drawn these diagrams. She says that the fractions are equal. Is Olivia correct? No, Olivia is incorrect, because she hasn't separated the top circle into fifths. She just separated them into 5 parts. And when we do actually put a bar model or a circle into 5 equal parts, and then the second one into 3 equal parts, we can see that 2/5 is greater than 1/3. Now in this session we're going to be looking at recognising and showing equivalent fractions with small denominators, predominantly represented on number lines. So what we're going to try and do today is we're going to use number lines to position our fractions, and that's going to allow us to see them in order to find equivalent fractions which are going to be the same size. So that idea of the unlike fractions that are going to look the same. Now turning to our textbook, we can see our first question relates to Kate's bracelet and the amount which is going to be different colours, because we can see the fraction wall underneath. For 1a we're told 3/4 of Kate's bracelet is blue. What other fraction on the fraction wall is equivalent to this? So for question 1a, 3/4 of Kate's bracelet is blue. What other fraction on the fraction wall is equivalent to this? So to help us answer this question, be thinking about what the picture shows. So how many parts does the bracelet actually have? And what fraction of that bracelet is actually blue? And what fraction of the bracelet is pink? Now, looking at that fraction wall, can you use any strategies you might have seen from previous sessions that allow you to find something which is the same length as the blue part on that fraction wall? So use the idea for blue part and think about what is the same length as that blue part. For question 1b, we're being asked to find another pair of equivalent fractions on this fraction wall. So we're just going to be looking for any type of equivalent fractions, any series of fractions which are going to be the same, using our fraction wall. So let's pause the video there and let's think about these two questions. So question 1a, you're being asked 3/4 of Kate's bracelet is blue. What other fraction on the fraction wall is equivalent to 3/4? And question 1b, you're asked to find another pair of equivalent fractions on the fraction wall. Could there be more than a pair? Are there any more? So pause the video and come and join me when you're ready so we can review the strategy you've been using. So let's begin by looking at question 1a. Now 3/4 of Kate's bracelet is blue. What other fraction on this fraction wall is equivalent to this? So we can see that we've enlarged the fraction wall slightly. And our first thing is, how many parts are there in total on the bar that show 3/4? So if we look at this idea of our blue, and now we can see exactly the same amount on the quarters. So we can see there's 3/4 of that bracelet which is blue, and I've highlighted 3/4 on the fraction wall with blue as well. Now we are looking for an equivalent fraction, which means we're looking for a fraction which is exactly the same amount. So looking at our fraction wall, can we see any others that would be the same length? And in this instance, when we look closely at our fraction wall, we can see that from 3/4, if we go straight down, we can see that 1/8 are the first ones that are in exactly the same line. And we can see that 3/4 is going to be equivalent or the same as 6/8. So 3/4 of Kate's bracelet is blue. What other fraction of the wall is equivalent to this? Well, we can see that it's 6/8. The other fractions aren't the same length. When we move on to question 1b, we're asked to find another pair of equivalent fractions on the fraction wall. And then, are there any other equivalent fractions? So again, what we're going to be looking at with this is this idea of drawing lines on our fraction wall. And by doing that, what we'll do is we'll find different denominators, unlike fractions, that are going to be the same length. Now all I've done on this is I've created number lines to show the bars, just to make it a little bit quicker. But if you notice, 0 is always in the same place. The whole, 2 halves, 4/4, 8/8 is always in the same space. We've got these bars exactly the same length. Now the first fraction I'm going to look at is from our top bar, so I'm just going to simply look at a half, and I'm going to see whether there's any other fractions that are going to be the same size as 1/2. And if we look down to my next bar, the quarters, we can see 1/2 is exactly the same size as 2/4. And if we move down to my next bar with 8ths, we can see that 2/4 are the same size as 4/8. So we've got 3 equivalent fractions here. We've got 1/2 is the same as 2/4, which is the same as 4/8. Let's see if there's any other fractions on this. So if we look at 1/4 on this bar model, we can see there's nothing on the halves that's going to be the same size. So let's see if there's going to be anything on the 8ths, which is going to be the same size or equivalent to 1/4. And we can see in this instance that 2/8 is equivalent or the same size as 1/4. And then if we take another fraction from our quarters, in this case our 3/4, we can see that if we draw a line straight down from 3/4, exactly the same length is going to be 6/8. So we can see from this we have our blue equivalent fractions, our orange equivalent fractions, and our green equivalent fractions, which can be recorded as 1/2 equals 2/4 equals 4/8. And we can look at our blue fractions of 1/4 equals 2/8. And we can see our green fractions, 3/4 equals 6/8. And here we can see 3 sets of fractions which are all equivalent or of equal size. And as with yesterday, I just want us to look at the pattern that you can see. So if we're looking at our denominators, for example, we go from halves to quarters to eighths with our orange fraction. What do you notice is happening to those denominators? What have I done to the 2 to make it 4? What have I done to the 4 to make it 8? And for this, think about multiplication. What have I multiplied 2 by to get to 4? What have I multiplied 4 by to get to 8? And then think about your numerator. I go from 1 to 2 to 4. What have I multiplied my 1 by to get to 2? What have I multiplied my 2 by to get to 4? And can we use those ideas to help us start identifying some other equivalent fractions? So when we look at 1/4 to get to 2/8, I've multiplied 4 by what to get to 8? Is there a link with what I've done to my numerator? 1 times something equals 2. And the same when we look at our 3/4 and 6/8. What have I multiplied my 4 by to get to 8? And is that linked to what I've done to my numerators? 3 times something equals 6. Is there another equivalent fraction that you can use and identify if you use that strategy? So now we've done the first question together, it's time to continue with your work in your textbook before you move on to the independent activities in your workbook. Now, again, my little tip is look at the fraction wall, use that to help, and be thinking about actually drawing lines to show you, because you're looking at this idea of equivalent fractions on a number line or a fraction wall. These equivalent fractions are the same length, they're the same size. And if you're thinking about that idea, it makes it a lot clearer. So looking at this very first question from our Think Together, we've got 0, 1/4, and we have to fill in the remaining fractions. But one thing I will leave you with is for A, the denominator will always be the same. For B, the denominator stays the same. For C, the denominator stays the same. And for D, the denominator stays the same. So don't expect me to have a number line in this instance with quarters and sixths. It will always be quarters. So be thinking about for each one. Take each of these questions individually to help you to be able to identify it, and then you'll be able to come back to this to look at that idea of, is it the same length, to see whether they're equivalent fractions. So good luck with completing the textbook and the workbook, and I look forward to seeing your work on this one and joining you next time to see how we can continue with our journey on fractions. Good luck.